I have a question for you. Is the addition of continuous functions a continuous function itself? So if I take two continuous functions and I add them together, is that going to be a continuous function? Well, let's find out. There are two properties you need to know for this. The first one being, what is continuity? So essentially, if you have, well, first of all, you have to establish whether you're talking about continuity over the whole domain or over like in a specific point. Here I'm talking about a specific point. I guess you can then from that argue that, okay, you take an infinite number of points over an interval, and then if you check all of those through whatever means possible, then you can figure out if it's continuous over the whole domain or interval or whatever you're looking at. Here I'm just looking at a point because that's the simplest case, and I think that, it answers the question. So if you're continuous, if a function is continuous at a particular point, what you need is your function evaluated at that point. So I'm going to call it f of c. So c is the point we're looking at. And f is, of course, our function. If f of c is equal to the limit as x approaches c of f of x, that means that f is continuous at x equals c. So what that requires is, of course, f of c to exist and the limit of x approaching c of f of x also existing. So if they both exist and they're equal to each other, then that function is continuous at that particular point. So then we need a second function to add them together. So g of c also has to be equal to that same limit, just evaluated at g, or for g. So let's say if we take f of c plus g of c, is this continuous? Well, let's find out. So we can actually just substitute these, we can kind of take the limit, replace it with that. So this is going to actually be equal to the limit as x approaches c of f of x plus the limit as x approaches c of g of x. Here's the second property that I was telling you about. Here's where it comes in. In order to proceed, you need to know that the limit, the addition of limits is equal to the limit of a sum. So the sum of the limits is equal to the limit of the sum, essentially. So what that means is if I take two limits and add them to each other, I can also represent that as the limit as x approaches c of the addition of the inside, so f of x plus g of x. All right, and so now what we have is that f of c plus g of c is equal to the limit as x approaches c of f of x plus g of x. And if we take a new function h, and we say h of x equals f of x plus g of x, what we've established is that h, so this is equal to, so I'll say h of c, which is what that is equal to the limit as x approaches c of f of x plus g of x, which is h of x. And that establishes that h, or otherwise f plus g, is continuous at x equals c. Now, you didn't necessarily need to introduce the function h into this. You could have done without it and just kind of notice that this is equal to the limit, which is kind of the same pattern here. But yeah, you can totally do it just by introducing a new function. So that hopefully answers the question. Now let's take it a step further. Can we work the concept of linearity into this? So what I mean by that is, sure, we've established that the addition of two functions is continuous as long as those original two functions are continuous themselves. But what about if we take, the idea of, taking a f of c for some constant a plus b g of c for some constant b, and, assuming that f and g are both continuous, is this combination going to be continuous? So it's essentially the same as this, but with coefficients in the in front of them. So I'm just going to put that a is a real number and then b is also a real number. Just maybe not 0, because then that's kind of boring, but it totally technically could be 0, so I'm not going to make any exclusions. So essentially, what we need to figure out really is if f of x is continuous at x equals c, does that mean that a f of x is also continuous at x equals c? Well, that's also pretty easy. We can simply just use, let me just draw a line there. We can just use the fact that, if we have a f of c, this is going to be equal to a times the limit as x approaches c of f of x. Let me move out of the way. And so then from here, we can just remember that you can kind of, move this constant inside of the limit. That's yet another limit property. So then this would be equal to the limit as x approaches c of a f of x. So then what we have is a f of c equals the limit as x approaches c of a f of x. Same sort of thing that happened here. You could again introduce yet another function to show that, but I think that we've actually shown that pretty well. So what this means is that, if we did the same thing for b g of c, then we'd get the same result, because the only difference is the actual constant and function. But yeah, we get the same result, and therefore, if f and g are both continuous, then we not only know that the addition of those two functions is continuous, we also know that the constant multiple applied to those functions is continuous, and therefore linearity applies. So, I guess the linear combination of f and g are also continuous. So I know there's a lot of mouthful, and I didn't want to make it confusing, but I know just the nature of this question can be a little confusing and tongue-twisting, but I hope this made sense. If you have any questions, let me know in the comments, and yeah, I will see you in the next video. Bye guys!